in the field because there's so much resources to learn. And I think it's very well documented and there's a lot of tutorials online that you all can look at. But like if I look at it as if I can do it, you all can do it as well. So hopefully, inshallah, you all learned something today and are able to practice this in real life applications. So some of the things that we will be talking about today, we'll be going over what is a large language model, an LLM, what is retrieval augmented generation, what is RAG, and then I'll also be talking just very quickly about what does fine-tuning a model mean versus the topic for today, which is RAG, when to use one or the other, and what are the advantages of both. And then finally, we'll walk through a little code example that I put together if you all were able to access the Google Drive earlier, you might have seen the Google Colab link at the end of the slides. We'll be going through that, and hopefully everyone will be able to run an example of RAG. Moving on. So what is a large language model? And I'm going to be talking in very simple terms. If I'm talking too simple for you all and you'd like me to be a little bit, give more detail, please feel free to stop me and tell me that, hey, you want more details. But also there's a lot of documentation online. And for some of these basic topics, you can even just type into ChatGPT to ask questions, and ChatGPT will give you much thorough answers than I could at this time. But if you want even to explain to you like a 5-year-old, you can even through ChatGPT. So yeah, just there's a lot of ways to learn more about these things. So I'm just going to go very briefly and high level on these topics. But first off, yeah, a large language model is essentially just a model that is designed to basically generate and understand human language. How it works is you basically give it a bunch of text, like a question you might have, or you want it to generate some text on its own. And basically, it does all this math and calculation in the background, and it tries to predict the highest probability of the next token, or in other words, the next piece of text. So in the diagram here we have, or in the image here, we have like, say you give the large language model a few words like the cat sat on the, and then what happens in the background, the model does some calculations, does some math to determine, okay, based on the context that I have here, what is the most probable word that would come next? It does some calculations, and then the better the model, the better the probabilities are. And then it gives you the next word and it chooses from whatever the highest probability answer is. And you can tweak these parameters and all these things, but I'm not going to go into too much of that detail. But at a high level, a large language model is a very powerful text generator and a text predictor. So it tries to predict what the next text is going to be in any given situation, whether that's answering a question or generating some code or anything like that. So moving on to what is the topic for today? What is retrieval augmented generation? What is RAG exactly? So I have some words here on the slide, but really how I like to understand and how it really helped me was you all know Google, right? You all can go on Google, you can type in whatever question you have, and Google does its optimizations, its search, whatever in the background, right? And it returns to you a bunch of links, even has the ability to maybe highlight some text that are relevant to your question. This is all great. Um, However, sometimes what if you want, and Google's starting to do this now actually, where they have, if you notice, they start to have some AI generated it with some of their questions and answers. And I believe at a high level, they are kind of using RAG for that. It's probably very optimized, but at a very high level, it is some form of RAG. But basically, where you want to use RAG is say you have or say you ask a question and you don't just want to get a bunch of links, you want something to be able to comprehend those links and then give you a concise answer at the end. And on top of that, you can't really use Google search on like say private data or in reality on proprietary data. So like say you're working with a company, they have all this custom data and financial data maybe that they don't want to put up on Google, right? And so you can't just control F that data through Google, or you can't just query that data through Google. So you want to be able to somehow query that data in a human text generated way where you can just talk to, or where you can just basically say basic English prompts or basic English questions towards a bunch of your data or documentation. So you might want to ask, any given question about any type of documentation that you have within your company. So once you do that, you're basically asking the question. RAG allows you to use an LLM to basically go and search the documentation that you have, and it gives you a result, which is essentially a comprehensive answer based on all of the documentation that's relevant to your question. And all this will make more sense when we go through the examples and stuff. So don't worry too much if it's not making too much sense. Another quick example that might make a little bit more sense is say you are a student and you have to take an exam, right? Um, with a basic model like say ChatGPT, which isn't necessarily using RAG, the student in this case would be ChatGPT or would be the large language model. If you are to integrate RAG into the system, RAG is like essentially like you're the student and you're taking an open book exam, where RAG allows you to search databases, search documentation in real time. So you can query that documentation in real time. Whereas in an open book exam, you're basically looking for answers in real time when you're taking that exam, and you have that available to you. That's another way to look at RAG is just having documentation available to the model in real time while you're asking it questions so that the model has a better understanding of how to answer your question appropriately. And this here is an image that I got from another website that I thought was pretty good. Maybe it can help you all understand RAG a little bit better. To understand this image, I'd like to start at the top here under the indexing box. So essentially, like I mentioned, a lot of times you want to do RAG on, say, proprietary data or just a bunch of documents that you might have sitting around. So again, we start with having that source of documentation, having that database of information. So one thing to note about large language models is that you can't just feed in all this text of information at once into a large language model. You have to chunk or you have to make that documentation smaller. So imagine you have hundreds and hundreds of PDFs, or imagine you have say 1,000-page PDF, right? So say you have 1,000-page PDF, you can't necessarily feed that into a large language model at once, just because of some of the limitations on something called the context window of a large language model. So what you want to do is you want to chunk that PDF of text, that 1,000-page PDF of text, and you want to create smaller bits of that PDF. So what I mean by that is you can maybe chunk it up into pages. So basically, one chunk would be equivalent to one page of text, and that one page of text is getting passed on to the large language model, if that makes sense. So you want to first off take all your documents and essentially shrink them or make them smaller so that a large language model can ingest them and understand them. So once you have those chunks, like I mentioned before, large language models do a lot of math and probabilities. So what ends up happening with those smaller chunks is you essentially do something called vectorization. And I'm not going to get into too many of the details on this. You can read all about it if you are very interested. But basically what you're doing is you're converting all of that text that you have in, say, your PDF, you're converting all of that text into numbers, essentially. And those numbers are then stored in something that you'll see us using called a vector database. And in the code example that I walked through, you don't have to really worry too much about all of this. There's pre-existing code out there that already lets you do all of this. So it's not as complicated as it seems. And this vectorization and all that is done in the background, so you don't have to worry about it. You just write a couple of lines of code and it'll handle it for you. So again, you take your documents, you chunk them into smaller bits of text, and then you convert them to these numberized vectors, and then you store them in something called a vector database. Okay, so now we have our documents chunked and vectorized into this vector database. How we actually use RAG is you're the user here, right? And now you have a question, say like a general Google question, like what is the capital of France? Whatever, like something complicated, maybe something relevant to the documentation, right? So you have your general question. It could be about your proprietary data, your company data, whatever. You ask that question in the form of text, in the form of human input. And then that human text, that input, again, also gets vectorized, also gets converted into numbers. Those numbers are then sent to the vector database. And what happens in the vector database is the vectors, the numbers that you sent to the vector database, is then compared to all the other vectors that came from your chunks. And then basically the magic, what's happening in the background is the code is looking for the most similar vectors from your documents that that are most similar to the question that you asked. So it's looking for all the text that is relevant, essentially to how Google works, right? It's looking for it's just trying to look for the most relevant pieces of information from all the text that could be relevant to the question asked by you, the user. So what it does is it tries to match the highest relevant vectors, and then it returns the highest relevant pieces of text or the highest relevant chunks. And in our case, like I mentioned, we chunk them into like, say, 1 page per chunk. So it would maybe return maybe say like 3 to 5 pages of text, maybe. So these relevant contexts are equivalent to your maybe 3 to 5 pages of PDFs that it said was relevant to the question that the user asked. So the code has now generated a bunch of pages of text that it thinks is relevant to the answer. So remember when I said this is like an open book exam? So essentially, this part here, this augment box here, and the relevant context, think of this as like cliff notes, like or like you had like highlighted some pages in your document in your books that were like bookmarking them essentially, saying like these are very important for these certain topics, right? So now that we have the most relevant pieces of information for the relevant question, the large language model then takes those relevant pieces of text, takes those relevant pages of PDFs, and then it takes the question that the user asks, and then it formulates an answer using those relevant pieces of text, and then formulates a comprehensive answer, and it gives you back the response. So basically, what ended up happening was you, the user, you ask a question, some magic numbering happens, you the vector database returns a bunch of text that it thinks was most relevant to answer that question. A large language model then uses those pieces of text as background information to then help the large language model answer your question. So basically, it's just retrieving some similar text and answering your question using that similar text. And again, we're going to go through the code, and hopefully it'll make more sense there too if this isn't clicking for anyone. All right. And then, so one last thing before we do dive into the code, I did want to touch on this very briefly. There is another technique called fine-tuning a model, or fine-tuning a large language model. This is where you train an LLM or a large language model on a big chunk of information, or a large amount of information. So like you can think of this as like maybe thousands and thousands of documents that you want to train a model on and make it more adept at that area. For instance, say you have a bunch of documentation on like say several video games, maybe there's strategy guides or whatever. Say you have like thousands of strategy guides on video games, right? And then you take that set and you basically take all that text and then you train a model on that so it becomes more adept at learning at how strategy works in video games, for instance. So that is one example. So like, and going back to kind of like the closed book, open book analogy that we were using, when you fine tune a model, you're essentially looking at something like a closed book exam, where you're basically, where the LLM again is the student. And when you fine tune it, it's basically like you, the student, you're in your class and you're just learning at one time and then you're taking an exam. There's no open book. So basically, feeding that large amount of information is the same thing as you going to class every day and just learning, right? So that's essentially the idea behind fine tuning is the LLM is basically a student and you're trying to teach it by feeding it hundreds and hundreds of bits of text or information and hoping something sticks. So there's some benefits to that. There's some downsides. One of the biggest downsides to fine tuning is that it requires a lot of compute power. So this isn't very practical for just students in general and just like solo practitioners, people to just want to do this on their free time because it takes a lot of compute power that requires a lot of money. Um, and so like it's a very compute intensive thing. So this is something you could look at in terms of like working at a bigger company or like if you end up having this compute power, this is very useful. But that is one of the biggest drawbacks to fine tuning is that it just requires a lot of power as well as time to run. However, with RAG, it doesn't require much compute power. You can do it on just about your local machine. Like today, we're going to go over the RAG example. You can run it on Google Colab. You can run it on your local computer. And so again, you don't need that much compute power to do that. So that's a big benefit of RAG. On top of that, like I mentioned, RAG is like taking an open book exam, right? So you can do it in real time with real time data. So you can, in your RAG system, you can feed it real time data. So you're never behind on the times, so to speak. So like with fine tuning, when you're teaching it information, say you went to college, say like I went to college like 10 years ago, right? Like um whatever I learned 10 years ago, that's essentially like static data or that's essentially like old data. Same thing with fine tuning. Whatever I teach it today, it'll be obsolete in a matter of weeks, months, or whatever, right? So that's another downside of fine tuning is that it's going to be trained on some finite and static data, and that data can change over time. And so RAG is a real boon for RAG is basically being able to query data in real time and have updated documentation in real time. And again, lastly, like I mentioned, there's several websites out there. ChatGPT is out there. If you have questions, if you want to learn more about the details and how these things work, um, feel free to look up. And I'll point you to some links here too shortly. All right. Um, so feel free to follow along. I'm going to be going to this Google Colab link that I have on the slides. Um, and you all can join as well if you'd like. I'm going to Let me see. If you don't have the slides up, I've also posted the link in the chat if you want to follow along um, as well. So let's bring this over here. Okay. All right. So, if you have never used Google Colab, it's a great resource. It allows you to use, like I was talking about compute power, they have some free GPUs available for people to use for a limited time. So it's great, and you can do a lot of free coding on here. So that's why I wanted to use this and show you all. If you've never used this before, it's a great tool. If you have no experience with Python, that's okay. I'll try to explain the stuff as thoroughly as I can. Um, but feel free to copy and paste whatever code that you don't understand into ChatGPT. It might be able to explain it. Some of this code, it might not have been trained on because some of it is rather newer. And again, like I mentioned, like large language models, when they're fine-tuned on static data. So ChatGPT might not have information about some of the stuff that we're doing today yet, but it should have a general idea. But anyways, so yeah, so if you have the workbook and if you're following along, the first thing you want to do is you want to make sure that you're using a GPU. So I'm already connected to this thing called T4, but if you're not, what you want to do is click the down arrow on the right and then click on change runtime type. And basically here you can see you can either use a CPU, which is just like using your own computer, or you can use a T4 GPU, which isn't very powerful, but it is powerful enough to load up a small model, a small large language model that we're using. There's some other GPUs here, like an A100 GPU, that is very powerful, but you do have to pay for that. I don't know how much it costs, but it probably costs a little bit of money, but it is very powerful. And you can do a lot of powerful things with that like such as like fine tuning, like I mentioned before. So, yeah, if you have money, feel free to use that. But for today, we're just going to stick to the T4 GPU. I think you get like a few hours of use on this free version. So we're going to make use of that today. All right. So once you click that, you select that. You should have a check mark once the T4 has been connected. And then the first thing we're going to do is we're going to install our Python libraries that we need. And so all you do is just click play. And this should take a couple of minutes. So in the meantime, we'll talk a little bit about some of the things here. So we're going to be using something called LangChain. LangChain is good and bad. It depends on who you ask. But I think it's a great place to start. It has good documentation and it has tons of examples and very easy to follow examples that work out of the box that you can run on your computer. Um, but it has a lot of integration with other tools as well. But with LangChain, you can do a lot of things like chat with your own large language model. You can use RAG like we're doing today with large language models. You can build something called agents, which I haven't talked about very much, but there's a lot of things that LangChain allows you to integrate with. So it's a great tool to and a resource to look into. Um, However, I do want to say that in production and like in like actual companies, if you want to like LangChain has a lot of like integrations with it, so it has some very messy code in the background. So like you don't necessarily want to use that on high scale applications, but like for like student projects, things like that, it's great. And for learning purposes, it is absolutely great. Like I suggest you all check it out if you're interested. There's hundreds of tutorials on it. And maybe if we have time later, I can show you the website and point a couple of things out. But again, LangChain is what we're using to run RAG as well as integrate with several other things. So LangChain community, similar things. But PyPDF is, if you're not familiar with that, will allow us to read in our PDF that I'm going to be giving it. ChromaDB is what we're using. If you remember that picture that I showed, that vector database, ChromaDB is a library that will allow us to use that vector database. Um, and then sentence transformers, something that allows us to like parse text and understand the human language. PyPDF2, another PDF library, parsing library. NLTK, another English text library. Transformer, and then the rest of these are all used to load your large language model. So, all right. So it looks like it finished. We have all our libraries installed. That's good. First thing we're going to do is we're going to import our library so that we can use them. So once you install them, you want to import your library so that you can use them and make sure that they install properly. And then these libraries here, like I mentioned, Transformers lets you load in large language models. And we're using something called Hugging Face. So let me quickly go to Hugging Face real quick. So Hugging Face is absolutely a great website, um, especially for students and just for personal use. It has tons of free models available, free large language models available for people to use. So for instance, um, where I'm looking at so Meta or Facebook or Meta AI, they have several models out there, like Meta Llama 3 8B. This is a really good one. But like basically what Hugging Face does is it's a website where you can basically go and download the models. And to do that, you basically just click download and just download all of these files into a folder and name it this path, and you basically have that model on your computer. I'm making it sound a lot bit simpler, but that's essentially how you can do it if you want it locally on your machine. But in today's example, we're actually going to load one via code. So um, because we're using a smaller GPU, we can't necessarily load some of the bigger ones. So we're going to be playing around with a small model, which is actually still very powerful. We're going to be playing around with something called the Phi 3 Mini. And again, we can just, uh, and how I found this model, again, you can just go on here, Hugging Face, and it shows you the model name that you want. And it's made by Microsoft. It's a relatively good model for its size. And because it's small, we can load it up onto this free GPU here. So that's the model we're going to be using, the large language model that we're going to be using for today's RAG and querying. So the next step is to quantize the model. So again, because we're using a free GPU, we have to make sure that the model fits onto this computer essentially. So we want to basically compress the model, and this is just a bit of code that compresses it. It's basically loading it in something called 4-bit. Basically, you're compressing it into 4-bit. And that's all you really need to understand. Nothing too serious there. You're just compressing the model so it fits on the computer. And again, and then so this line here, model equals auto model from pre-trained. I'm going to start pressing play actually because this takes a minute to run. But basically what this model, this line does is you're basically downloading the model. As you can see here, I'm downloading the model. And it's basically just downloading the model from Hugging Face. So I'm directly downloading it from Hugging Face. I don't have to do anything else. And again, I specified that it gets quantized into 4-bit so that it fits. But yeah, that it's as easy as that. So once this finishes downloading, you'll have the model loaded up on your computer on this GPU, on this T4, and we can do things with it. So you load that up, as well as we're also loading something up called a tokenizer. A tokenizer is very important because, like I mentioned, um, you want to be able to convert the text into numbers essentially. So like when you ask a question to an LLM, and in our case, we're asking the question to Phi 3 Mini, you want to be able to convert that text that you asked the question in into numbers. And then this tokenizer basically just allows you to convert that text into numbers without you having to do anything. So this tokenizer is very important, as well as the model itself. But basically, when you have a model, you also want to have a tokenizer so you can convert any text into numbers. And again, all the magic happens behind the scenes, so you don't have to worry about doing any of that math or anything. You just have to make sure you have the proper tokenizer for your model. And again, the most models come with a tokenizer. I'm using a different one, but it's made from the same family. I'm using a Phi 3 Mini 4K Instruct. I could use the same one, but I just wanted to show that you can mix and match as long as they're from the same family. But but you can have the same one if you want. Let's see. And it looks like check mark, so it looked like it ran, so that's good. So our model downloaded. And again, these are kind of hefty files. They're not very small actually. And this is considered a small one. So you can imagine as we get bigger and bigger models, like how big they are. And that's why it requires a lot of compute to like run powerful models and fine tune them. But anyways, these are all downloaded. The tokenizer is downloaded as well. And so we're ready to go. All right, so the next one, I'm just gonna click play on it, is we're creating a pipeline. Um, and best way to kind of explain this is basically like this pipeline is through LangChain. So basically it's just allowing you to it's basically creating a pipeline between LangChain and Hugging Face so that you can use the model within LangChain's framework, or basically whatever we're about to do with LangChain. It's basically allowing us to use the model, the Phi 3 Mini, with LangChain. So that's the easiest way to explain it, is just we're creating a connection between LangChain and Hugging Face, essentially. Um, and we're specifying some parameters. These parameters might be of interest to people. This max new tokens, 512. This means that basically a token is like a word. So like the word cat, that's like a token, perhaps. Like each model has different tokens or a token setting. So like cat could be a token, computer could be one token. But like basically this is saying this is how many words that I want the response from the large language model to be at. Like it should not exceed this many words, essentially. Um, and then another thing is temperature. So temperature is a value from 0 to 1. Temperature basically means how random the model will respond. So like the higher the temperature, the more random it'll be. So like for like factual, like work related questions and stuff, you might want a lower temperature like this 0.2. But for like a role playing game, say like you wanted an LLM to pretend it was like a character in Star Wars or something, you might want to have it very high so that it generates a lot of randomness and a lot of creativity. So again, the closer to 1 it is, the more random and creative it is. The closer it is to 0, the more factual and studious it is. All right. And then we're importing some more LangChain libraries that we're going to be using. All right, and then the next thing that we're going to be importing is so I click that, and then we're going to be importing something called the embeddings model. So the tokenizer that we looked at previously, this tokenizer um, helps with translating the queries that you personally give the model when you're asking its question. This embeddings model is used to basically, like I mentioned, vectorize or turn into numbers the PDF documentation that we're going to be giving the vector database. So this embeddings model, this sentence transformers all mini L6, um, this will be converting all the text from our PDF that we're going to be asking questions on into numbers, essentially. So this what converts and does all the magic in the background of converting text into numbers for a document. And then you can Google like different embedding models if you're ever interested, but this is a good one for you all to use. It works on CPUs, it works on basic everybody. It should work on most computers. So feel free to use it however much you want. All right, now we get to some good stuff. Okay, so all this time we've been talking about the model and whatnot, but what we want to do is ask questions on a real live document. So right now I just have, just for fun, I just uploaded an avatar Wikidata PDF. This PDF just has like, if I don't know if people watch, but Avatar: The Last Airbender, the cartoon. It's just a cartoon series if you haven't watched it. But this PDF just has some general information about the characters and some background information about the story. It's just a fun PDF that I thought everybody who did watch it could understand. And I uploaded it here. And if you are following along, to do that, you would click on this folders icon, and then you would click on upload to session storage, and then you just upload the file. The file does exist on the Google Drive that was shared with everyone. So if you want to use that one, you can. If you have other PDFs that you would like to just play around with and ask questions, feel free to do that. You can upload that one as well. I will say though, like the larger the PDF, the longer time it takes to like vectorize or numberize the document. So be wary of that. But if you have a small PDF that you want to play around with right now, feel free to upload that instead of the Avatar Wikidata that was in the Google Drive. Or if you just want to watch, feel free to just watch. All right, so uploaded the PDF. Now we're going to load the PDF and ignore all these warnings. I'm not even sure what they mean, but they're just that they don't mean anything right now. And then we're going to chunk the PDF. So remember I was saying like we can't just feed a whole PDF to a large language model or into the vector base. We need to chunk it. So basically like if you have like 1,000 pages in your PDF, you might want to chunk it into smaller PDF, smaller pages, maybe one page per chunk. And here we're chunking it into 1,000 characters essentially is one way to look at this. It's a little bit different than that, but basically the easy way to remember is we're basically creating a chunk of text for every 1,000 words, essentially. So that's kind of what we're doing here. So we've created that and we have now chunked our PDF essentially into several chunks of text. Okay. All right. So the next step is now that we have those chunks, we want to vectorize or we want to convert those chunks of text into numbers so that we can do the magic of matching numbers when we query the model. So this vector store line, this is using that ChromaDB library from earlier. It's creating a vector database for us all in the background. We're feeding it in the chunks of text. This persist directory just tells you where to save the vector database that it creates. And then the embeddings are the embeddings model that we used here that is going to be used to convert the text into numbers or vectorize them. So that comes from there. And then this line here, you don't have to worry too much, but basically what you're telling it is, hey, when the model looks at the vector database, return the top 3 most relevant chunks of text. That's all it's doing. So you could change this number to like 53 or whatever, right? And it'll return 53 chunks of text that are most relevant. You don't want to do that because most likely there's not 53 relevant chunks, so it's going to return garbage. So you want to keep that to a lower number so that it returns the most relevant pieces of text that are most common to your question that you give the model. All right, so we created that and you'll see that it creates like this SQLite file. That means that your database got created. It also creates this Jarble, I don't know what it is, but basically these 2 files are created and you have a vector database. Congratulations. All right, so now we import a couple more libraries. And then we'll press play on that. We'll press play on this template one. This template is just used so that the large language model that we're using, 5.3 Mini, knows how to ask the questions. The large language models have specific, some of them have specific formatting, and I gave you the format here. So if you ever want to ask questions, this is the format that you would use for 5.3 Mini. Other models have different formats, but there's tutorials on how you can do that. Most of the time, you can get rid of like these weird tags, and you can just have the information in between them. But for 5.3 mini, we have to add these tags here for in order for it to understand what's going on. But basically, we are telling the model that it's going to be provided with a question, and the model needs to go and find the answer to that question from the vector database. And in order to do that, it will receive some context from the vector database. It'll receive those three chunks of text that it thinks was relevant, and then it uses those chunks of text to answer a question that a user gives it. So we create that template so that the model knows how to ask and answer a question. Um, we put that template into this LangChain variable. And again, you don't really need to know the details. This is like boilerplate code. This is like code that you can just plug and play in a lot of places. So it should work. But again, LangChain has all the details on like if you want to learn a little bit more of what's going on. But this is just setting it up so we can actually use the template that we have up there. And then finally, more libraries because there's so many in LangChain. Like I mentioned, like LangChain is great, but it has a lot of like dependencies. It makes you require a lot of libraries and things like that. But for learning purposes, it's pretty good because you see a lot of things and you're exposed to a lot of things. So, but anyways, and then the final thing that we have to do, this is just, again, just code from the website. I'm not even going to spend much trying to explain this code, but this is just how you essentially use a model to query a vector database. It's a little bit complicated code, but you don't really have to understand it too much. You can just plug this and play. Really what you're creating, um, really what it's doing is you have that prompt format, you have the format that the model is expecting your information in. You're feeding that to the 5.3 mini, and then the 5.3 mini is answering the question based on the context that it received from the vector database, and then it's just parsed into human readable text. So it's a little bit complicated, this chunk of code, but you don't need to worry about it too much because this is pretty plug and play. You can kind of just use that whenever you want to do RAG with other LangChain models. All right, so finally, we get to actually asking the question. So to actually ask the question, we created something called RAG chain with source in the last chunk of text. But to actually ask the question, you do something called invoke, and then you type in your question here. So this is where all the fun happens. This is where you can ask your PDF whatever you want. Um, and yeah, so this is where it happens. And then you press play, and we'll see if it works right now. It might take a minute or two because basically what it's doing is it's looking through the vector database for the most relevant pieces of text that are related to what I just asked it. All right. So it looks like it ran. And so to get the answer, we want to print the answer. And for 5.3 mini, again, like I mentioned, it has like these weird tags that it needs to be able to like understand stuff. So I have like this just line of code here to kind of like parse that out for you so it's more readable. And so we're just going to read that answer and see what it says. So yeah, here we go. So Sokka's strengths lie in his ingenuity and his proficiency with various weapons. He is skilled in using a boomerang and a battle club and a sword and blah, blah, blah. So if you have watched Avatar, you know that's pretty accurate. And so yeah, I'm happy with the answer. So now imagine you were at a company, you're working for a company, they have hundreds of documents, and they don't want to go and read all of those documents, or say even you don't want to go and read all those documents to learn about something like it'll take you like hundreds of hours to learn about or whatever. Basically, you can go through all this code, you can use all that code, you can come here to this invoke method, and then you can just ask your question, and then you just parse your answer, or you do this bit of code, and then you can get your answer here. And yeah, so that's kind of in a nutshell using RAG. So we basically parse some PDF. We basically uploaded a PDF to a vector database. We downloaded a model from Hugging Face, and then we asked that model to search through that vector database to help us answer this question, and gave us a decent answer. So yeah, it's pretty applicable to a lot of real life scenarios. A lot of companies are looking at this and are looking to do this for their real life use cases. So if you can maybe show them something like this, like you'll have a big leg up. A lot of people are just asking, what can we do with AI? And they have no idea. But like this is something very, very simple that has a lot of reward in it, I think, up front. And I think you could really impress people with it. Especially like I mentioned, you guys are at a prime area where like people are just getting into this stuff. So whatever you're learning now will be you'll be leaps and bounds ahead of people in the real world who are just asking, what is AI? Like if you can show them something like this, even with your own data, I think people will be impressed. Even if you don't come from a computer background, but if you can show them this and explain how it worked, even to some extent, I think that would be very, very great. All right, so we're coming up on time. Let's see. Yeah, so we're coming up on time. So I think there's like 10 minutes left. So before, if there are, I'll stop here for now, but are there any questions from anyone on the line? All right, cool. Well, um, if not, that is all right because I wanted to show something else. So this RAG workshop file, this Python file is also in the drive for you guys to use. Um, this allows you to play around with models on your local machine without Google Colab. If you do want to run on your own machine, it allows you to do, it allows you to use something called Llama C++. Basically, yeah, basically Llama C++ lets you, like the model that we downloaded, the Phi 3 mini model, basically it lets you download something called a GGUF file, or it lets you compress that model even further into a single file called a GGUF file. And basically you can point to that file, and use that as your model instead of downloading from Hugging Face directly. So you can have this file downloaded somewhere on your machine. So this is where it's downloaded on mine. And you can use that essentially with Llama C++. But just want to show you that. So this is out there. Um, I will say if you can't get the Llama C, there are some issues with getting Llama C++ installed on your computer. So if you have issues, just you can try just the basic method, which was where we used Hugging Face's code, and just download it directly from Hugging Face and do that. But there's some good stuff in here. A little bit more comments in here. Um, I have some example code on how you can feed in multiple files um, into the vector database at a time. So it's not just one file at a time, because in the real world, you're going to have hundreds of documents that you might want to feed in. So I have some code here if you want to use um, for doing that. But yeah, the rest of it is pretty similar. Um, I think you might, yeah, this part might need to be updated. I didn't have a chance to update it, but this part might need to be updated with the those special tags that I was showing you in the Google Colab. So you might have to copy the code from there. But other than that, it should run. So if you're ever looking to show someone some code that does AI, or someone ever asks you, what can we do with AI? You can show them RAG. It's pretty it's pretty solid example and a solid, there's a bunch of use cases for this in the real world. And I think it's a great barrier of entry for folks to get into. So yeah. All right, with that, and there's just some links here for LangChain, Hugging Face, and some other stuff. But yeah, thank you all for listening. And I hope you all learned something today. Um, see, I don't know if you guys just wait for the next post or whatever, but
We can start
oh,
if
okay.
you are done. Yeah.
Okay, sure. Yeah.
So, Brother Mustafiz, um, do you want to have anything else, or we can go ahead and get it started? Dr. Mustafiz.
He might have stepped away. I think we can just
Okay.
go on. Yeah.
I cannot share my screen, and I think we have to also give Dr. Mahmoudul Hassan permission to share his screen as well. Do you have access to, are you a co-host for this meeting? Yeah, can you make us co-host as well? Mohammed Islam and Mahmoudul Hassan. So share our screens.
Where is that option exactly? I'm not sure if I host tools. Hold on. Yeah. Host, is it under host tools?
If you
I can do it. I
Okay.
can do it. Hold on. So, Brother Faisal, let me do it. Hold on.
Yeah. And then please also make Mahmoudul Hassan, Dr. Mahmoudul Hassan as a co-host as well.
Wait a minute. Let me see. Where are you? Mahmoud Hassan. I got Mahmoud Hassan.
Yeah.
Make co-host. Okay, he's done. And yeah, let me see yours. Are you using your
I'm Mohammed Islam.
Muhammad Islam, right? Okay.
That's my
Muhammad Islam, I found it. Make co-host.
okay.
So you are co-host now.
Okay. Jazakallah khair.
So is it streaming now?
I don't know about the streaming, but you can check. Maybe I can check as well.
Okay. Let me stop the live.